Hello and welcome to this repair tutorial, and today we're going to look at a NAD C352 amplifier. So this amp was released around about 2004 time frame, and in terms of specification you can see here that we have a power output of 80 watts per channel, and that was delivered into 8 ohm speaker loads, and then frequency response is 20 Hz to 20 kilohertz, and then total harmonic distortion is 0.02%. And then input sensitivity, because this amplifier didn't have a moving magnet or moving coil input for a turntable or high level, is 770 millivolts. And in terms of input, you could connect directly CD player, video, recorder, tuner, disc, auxiliary, and tape 1 and tape 2. What is common also with this amplifier, as with the other C series, is you have the option from the front panel then to have tone defeat. And that simply bypasses the tone control circuits for the amplifier, so that just means that you wouldn't, for example, be operating treble and bass controls. What's a nice feature is the amplifier supports 2 preamplifier outputs. Preamplifier output number 1 will connect via the metallized links, and I'll sort of show this in the video, where if you chose to, you could just separate the preamplifier and then connect to 2 external power amplifiers. But if the links are installed, then it will use preamp 1. But you still have the option then to use preamp output 2, which is a nice feature, as I said. From the rear you have a slide switch, and this will then select what we call soft clipping, and then from the front it will be denoted by the LED which will illuminate. And really what soft clipping is, it's a NAD feature which really prevents the operator from overdriving the amplifier, or maybe if you're playing music at fairly high volume where you'll have an increase in audio. Maybe in a music track, it would then just help just to clip that down. And then dimensions wise, so you're talking height is 100 millimeters, and the width of the amplifier is 435 millimeters, and overall depth is 290, and it comes in at a decent weight of 7 kilograms. I do actually like this amplifier. It also supports a full remote control, and when you look at the remote control that is provided with this amplifier, it's chunky in design, so they really haven't compromised. And when you press any of the push buttons on the remote, you get this nice tactile feel, because they're like silicone rubber type keys, and just powered, you know, from two batteries which are readily changeable. And you can do everything from the front panel as you can then from the remote. So if you wish, from the remote control you can place the amplifier into standby mode, and you can select any of the inputs, operate your volume control, etc. What it doesn't support is dual speaker outputs. So what I mean there is, for example, having speaker set 1 or speaker set 2, it just has the single speaker connection on the rear. What you also notice as well is you have the headphone socket as well, and that is common with all of these amplifiers. In terms of other units within this range, people will be maybe familiar with the C370, which is the bigger version of this amplifier, and then also the smaller version, which is the C320 series. Again, very, very popular amplifier. So what was the issue with this amp when it came into the workshop? Well, it had a number of issues, and the issues with this amp really was intermittent start. So the power button could be selected, and then when you press the power button, what will happen is that the amplifier, then the LED above the power switch will just show red, and that's really in its standby mode. And then if you operate it from the keyboard at the front or via the remote control, what you should find is that the amplifier then comes out of standby mode and the power LED should turn to green. Now what you found with this amp was sometimes it would and sometimes it wouldn't, but it's not uncommon to find these amplifiers where it's just stuck in this standby mode. And the reason for that is due to the electrolytic capacitors which were used on these series of amplifiers, and they were manufactured, or a brand called JH. And I've sort of done this on tutorials previously, and on the many repair description videos that I've put together. Really what you have is capacitors which deteriorate over time, as they do. But for this particular series, it would appear that they go extremely low in value, and then you'll also have a very high ESR. So what you were seeing here was that the capacitors were just kind of on the borderline of failure, but you were getting this intermittent start issue. The other thing was that when you could get the amplifier to start up, and it came out of standby mode, from the front face, if you selected the different inputs, what was interesting was that the CD input, although it would select it on the board, you didn't have the illumination of the green LED, and then that was an issue again which needed to be rectified and repaired. Now what I show in the video is just the top layout of the board, and again I sort of draw your attention to the layout of this amplifier. It's a common NAD design, but what you'll notice is that you're really in this era where they've moved away from mechanical type switches, but on this amplifier they didn't use a solid state input analog switching circuit like a custom made IC by Toshiba, which would handle all of that input selection. What is a nice feature is you have these individual relays, and then as you will select the different inputs, the microprocessor then will send the command signal, and via the relevant switching the appropriate relay will then energize, selecting that input. So you have nice input isolation, but at the same time it's more of an expensive or upper market type design then. And then in terms of, you know, the sort of work that you would then carry out and how you sort of approach this, and again I often use this word where I say that, you know, you need to take a systematic approach, and that's exactly what happens here. So the first thing that I'm going to do is I'm going to look at all the different types of electrolytic capacitors. If you refer back to the service manual, it's very, very easy to just collate a complete list giving you both the operational temperature of the capacitors, also as well what is the microfarad value, and then also the voltage as well. Now it's up to yourselves. If you're recapping an amplifier, you may go out and source different types of brands of capacitor, but for this amplifier really it was selected that it would be Nippon, and these are the Chemicon capacitors. So these capacitors were ordered directly from Musa, and they arrive in a couple of days, even though I'm based in the UK and they're shipped you know, by aircraft, you know, into the UK directly from their centre in the United States. But to sort of give you some kind of idea of what it will cost you just for the components themselves. So in the UK, because you were above the minimum order value for Musa, which was fine, they weren't charging you shipping, and they will handle any of the import charges or duty due on that import in the UK. So if I added together all of the costs for the electrolytic capacitors, and then I also added in there as well the speaker protection relay, because of the amplifier age it was replaced, then the approximate cost is about £53. Okay, so those are Japanese capacitors going in to really refurbish this amplifier, and that's what you're kind of looking at for your parts cost. I appreciate that if you're based in a different country you may see some movement around that for exchange rate reasons, but that's what you see in the UK. So you could buy even more expensive capacitors if you wish, or you could go lower if you wish. It's up to yourselves, but that was the brand that was then selected then. And then what I do here is the first board that I concentrate on, and I show you this in the video, is that I focus on the power input stroke startup board, and this is where you have these large electrolytic capacitors which are shown. Now when you remove the electrolytics, although they are to all intents and purposes have a NAD branded capacitor, of course they would have been built or manufactured by an OEM under license for NAD. And what you can do is, of course, you can test the capacitors on your ESR meter, and what you'll find is in this case they were probably 40% lower than what they should have been in terms of actual value. But the other thing that you notice, and this is very, very common with these large electrolytic capacitors, is if you give them a shake they actually rattle. And what's happened there is the electrolyte is pretty much all dried out, and what you have is this cardboard insulation. And I'll put a link in the video to a tutorial which I did some months back on the design and manufacture of capacitors and different types, and it sort of gives you insight into how these capacitors are manufactured. So they will rattle, so you know straight away, you know, the capacitor has got to the point of failure. Now the thing with electrolytic capacitors are, depending on where they're in the circuit, they will work extremely hard in some cases and less so. So when you see these large power supply capacitors, they're in a hard life. So that means that they're handling high current for the amplifier. The current must be available on demand. And because this amplifier really was sort of failing to kind of come out of standby mode intermittently, that just told you that the amplifier was struggling even on the startup side. And I appreciate, I've mentioned this on other tutorials, you can go out and purchase these kits which are for the protection circuit, But realistically, when you're looking at this amplifier, you might as well just recap the entire amp, because if you're just going to do a section of it, then you'll soon discover that, you know, these large electrolytics will fail. So systematic approach. So what I'm doing here is I'll replace the large electrolytics, and then there's some smaller electrolytic capacitors on there, still the same brand JH, and they get repaired. What I'm also looking out for is this brown glue, and I mentioned this many times. They use the brown glue on many of these amplifiers, and the issue is it's both corrosive and conductive. So just get that out of there, don't have it, remove it at all costs then, and that just provides that longevity on your repair. And then I'm also scanning the board as well for dry joints. Make sure that there's no dry solder joints, and you will always get dry solder joints around any component which is running hot, like power resistors or power transistors or regulators or driver type transistors. And later on in the video I also show you this, and what you will see is that you see some of the transistors, for example, which are running fairly hot, and then you have almost like a grey effect around the solder joint, and you can see that it's starting to break down. So it's very important that when you're doing the main capping of the board for the amplifier, that's what you got to go focus on, right? Don't just replace the capacitors and then sort of power it up. You know, scan that board and make sure that you're not looking at any dry joints, reflow as required, and then, which is very common, once you've done this recapacitor or recapping, just check the board over, make sure that you don't have excess flux, and you can use a flux remover, you know, to sort of take that away. And then other sort of guidelines for yourselves when you're going through this, and this is really important here. So what I'm showing now is the overview then for the power supply and the startup side of the circuit board, and then what I'm highlighting of as well is the standby transformer. And what it also will do via the microprocessor is it energizes the power relay, which will provide power then to the toroidal. Now remember, this amplifier has been running for, you know, literally decades. So what you need to do, and this is very easy, you can remove the top of that relay. I just desolder it from the board, and then what I'm checking is the switching contacts, and often you'll find some degree of oxidization, but there was no pitting, so it's quite straightforward that I could change or I could clean then the switching contacts of the power startup relay and then reinstall it into the board then. And then the other part that I'm showing you is, this is where we come then to the next part, where we're showing the issue then with the keyboard. And they refer to the keyboard is that board which is shown in the video, but that board is not just a keyboard, it also has the microcontroller on the board as well. And then if you look from the rear of the amplifier, you have a very nice metal screen on the back of the amp, on the back of the board, and that's really good design, because, you know, even in these sort of earlier days when they were using, you know, early microprocessors, you know, issues associated with noise and random operation of a particular feature or function with any device which had an early microcontroller needed to be avoided. So that's why you often have these very smooth power supplies, so there's no noise or noise to an absolute minimum, and some degree of screening. And then what I'm showing on this overview schematic here is I'm pointing down to the component reference, which is D703. And D703 is the green LED, which is for the CD selection. So you may ask the question, well, okay, how do you determine if the LED has failed or not? Well, you can remove it, and then you can do a measurement on the diode test on your multimeter to check whether or not the LED is open circuit or it's not. What was interesting here, and you can see the circuit schematic, that once the microcontroller drives the command, it then will illuminate the LED, and you can see it's via associated resistors and capacitors and a switching transistor. So that just means that there's some noise suppression in there, so you don't get any sort of random operation, and it's very clean in terms of switching. But when this LED was removed from the board, it wasn't fully open circuit. It had just sort of gone, you know, kind of almost resistive. And easy way to do that, if you don't have an LED in stock of that particular time, I'll come to that in a second, you can just remove one of the other LEDs and then just switch them over and then retest then, and sure enough you could see that it then illuminated. So the specification for the LED And again, many years back, you commonly had LEDs which had a fixed voltage range, and they were either like 3 millimeters or they were 3 millimeters in term of, sorry, 5 millimeters in diameter. So this LED here is 2 volts. So if you're looking to replace the NAD LEDs on this unit, it's a 2 volt 5 millimeter green LED that you need to purchase then. And commonly these LEDs draw approximately 20 milliamps, and that's what it's designed. The reason why I'll raise that as a point, now you have a very broad range of LEDs available. Some are 3.3 volts, some can be higher, some even have their own internal regulators which are built in as well then. And then the other thing that I want to draw your attention to is the area here, and I'm pointing to a component, or I'm showing a component which is a resistor, and that is R281. Now when you look at the resistor, its actually value is 680 ohms and it's rated at 2 watts, and it's actually a feed resistor to Q163, which goes to the trigger output on the back of the amplifier, which could be used often. You don't always see it being used. Now this resistor here is what we call a fusible resistor, so that means it's a safety resistor, so in the event of failure the resistor would go open circuit. Now what you tend to find sometimes with some of these higher power resistors, and I've referred to this on a previous tutorial, is they just go stinky, and you think, well, what's this guy rattling on about when he says they go stinky? What happens is when you power up the amplifier and that resistor is doing its work, it hasn't changed in value, you get a particular odor that gets emitted from it, and it almost smells like a kind of an oldish kind of odor, and almost like something's burning. Because this amplifier really was a refurbishment, you don't want a customer to sort of have it playing away. They sort of leave the room, and we've all done this. You come back in, you kind of back into the air, and you think, that's an unusual smell, it's something burning. And that's what you saw with this amplifier here. So rather than leave that resistor in there, it was functioning, I just took the time then just to replace that. So I'll replace it then with a brand new 680 ohm 2 watt fusible resistor. And then when the amplifier was under test and then operating, there was none of that sort of strange stinky smell, which was then coming from the previous resistor. But if you kind of come across this, your sort of choice, if you want to change it, I'm not saying you have to, but as best practice, I change them out. And then I also show as well on the video, which is on the top board, what you'll see towards the rear by the speaker terminals is the original switching relay. Now again, I could, if I wanted to, sort of do something with that relay, maybe trying to open it up, but I just replace it. I put a brand new sealed relay in there with gold switching contacts, and that relay then will ensure longevity for future operation. And then the other part, once you've done all of the recapping, you've checked all of your dry joints, you make sure that they are okay. You can also clean the user control potentiometers with a high quality contact cleaner like De-Oxit, and that's what was done here. And you can also squirt it directly then into the tone defeat switch. Sometimes you might get a little bit of noise, if these amplifiers have been in storage or not been serviced at all. But after a number of operations backwards and forwards to click on, click off, you'll find that those contacts come up nice and clean, and you won't have any more noise then. And then really you're in your alignment phase, and that's an interesting one with this amplifier. It's not complicated, but it's probably different to some of the amplifiers that you would work on in terms of how you will set or correct for any DC offset. So what I'm showing here is an extract from the service manual, and we're just simply showing the left channel. So the first thing that you would do is power up the amplifier, understand it, but then allow the amplifier then to warm up, say for 15 to 20 minutes. So once it's warmed up, what you do is you just connect the negative lead of your multimeter to the negative speaker terminal, just as the common ground. And then what I'm looking to do here is I need to focus onto that integrated circuit, which is an operational amplifier. And you can see here it says IC107A, and that's because it's a dual operational amplifier. There's one for the left circuit, and there's also a second one then for the right circuit. What I'm doing is I'm just measuring the output on pin 1, And then what I'm looking to do then is to adjust VR101 to a reading which is less than 100 millivolts. Now what you'll find, and I've said this many times before you kind of do these adjustments, just sort of squirt, you know, some De-Oxit high quality contact cleaner just onto the preset potentiometer and just rotate it backwards and forwards a little bit, and what that will do is it will clean off any oxidization, and then you should be able to adjust this very, very easily with no sort of jumping around of the measured value. So what I try and do is, when I first connected it, it was probably about 90 millivolts, and then the right channel was about 85 millivolts, and that was more than good enough. You know, I could have left it at that because it's just saying less than 100 millivolts, but what I wanted to do was just to see if I could get that any better. And you can, you know, if you take a very, very precise adjustment, you know, I sort of got this round to about 10 millivolts to 6 millivolts, and I just leave it there, you know, for a few minutes, just stabilize out, and yeah, absolutely rock solid, no sort of drifting or anything like that. And then the next part is you need to ensure, of course, that you have no speakers connected at all, and that you also have your volume control set to minimum, your balance, treble controls, etc., all at midpoint. And then what I'm looking to do here is to adjust the idle current, and what you have both for left channel and right channel is you have two test points, and they're like pins which stick up out of the board. And then what I would say to you is, often just use some hook clips just to connect around these pins. Don't try and balance, you know, your sort of meter probes, because it's very, very easy for those meter probes just to accidentally slip, and you don't want to go down that route. So once that's on there, after this recapping, it was probably reading about 2.2 millivolts for each one of the channels, so low. So what I do here is I just make the adjustment. So here I adjust the VR103 after it's been cleaned, and I will set this just to about 5.6, 5.7 millivolts, and then I'll repeat the same exercise then for the right channel. And then I'll leave the amplifier running again probably for about 30 minutes, and then I'll recheck what these values are. So I didn't need to make any final adjustment for the output offset, but there was just a slight amount of increase in terms of drift for the idle current, and then I just brought it back to about 5.5 millivolts. And then you can quickly verify to check the DC offset if you just connect your multimeter across each one of the output speaker terminals and just measure what that value is. Now if it was excessively high, what you would have found is that the protection circuit would have come in and then operated. What's really nice for this amplifier, once all the work had been done, literally you were looking at this, it was about 1.2 millivolts, if that. It was extremely low, which was, you know, really, really good to see. And then the final part was then just to put the amplifier under a full operational test, and the amplifier, you know, ran faultlessly probably for about 3 hours in total. And again, you know, there's like a test routine where you can check the total harmonic distortion of the amplifier, just verify that it's working correctly, and also a number of starts and stops then. And then once that was done, all work completed, and all that remained then was just really to clean the amplifier. As I said, you know, I do like this amp. You know, in terms of design, it's really, really good. Music quality is excellent, but when you look at the front fascia, and of course I needed to remove that to get access to the keyboard and the micro board, that front bezel is machine metal. It's not plastic, and you can feel the build quality of the amp. And you know, once this amplifier had been recapped and all the work had been done, you know, you just listen to this thing under test, and yeah, you know, the sense of achievement that you get from that, you know, it's just a great feeling. And people who restore audio equipment, you know, I've worked on a lot of different equipment, you know, it could be television, doesn't matter what it is, but there's something about audio amplifiers when you do this restore, just gives you that tremendous sort of pleasure and feedback to restore it. And it's just a shame that, you know, a lot of engineers have sort of, you know, closed up shop or got out of the game. But for myself, you know, this is something which I absolutely love doing. I think you kind of figure that out on some of the tutorial videos, you know, that I'm putting together now. But yeah, if you can, you know, just take the plunge if this is the first time you're looking maybe to work on an amplifier. But restoring any piece of electronic equipment is an absolute pleasure. So that kind of brings us to the end of this repair tutorial. And as always, I really appreciate you stopping by and then listening. Hopefully you've learned something, and at the same time you can apply this information, you know, to any other amplifiers that you're looking to repair. And if you need any help or support, by all means email Audio Amplifier Servicing at AOL.com, and I'll be more than happy then to come back and provide you with the information or guidance that you may require. All right, so wishing you all the best until the next time. Cheers, bye bye.